let us try to work out some of the problems in today's session. Okay, so before that, I would like to show you something. Okay, I hope you can recall the kind of the concepts we learned in the last class. One is the energy signal, another one is the power. Okay, for power, time t tends to infinity, 1 by t you have to put. But here also we are talking about time t tends to infinity, but we are not averaging over. Okay, so that's different. So here we are averaging over 1 by t. So for periodic waveform, you won't get energy. Okay, you will get infinite energy. It's not feasible to compute energy. So you should know whether the given signal is a power signal or an energy signal. Based on that, you have to work out. So that's what we learned in the last class. Along with that, I wanted to tell you a few new things. I hope you can recall that. So how many of you worked out this one? I hope you can recall this. How many of you solved this one? Un minus 3k minus un minus 4 minus 3k. Is it possible for you to work out this? Anybody in the class? Gokul, putting on the problem. Did you work out the problem?
இல்ல சார் போல சார் நீங்க இன்னொரு தடவை எக்ஸ்பிளைன் பண்ணுங்க சார் நாங்க
okay fine. So that's not a big deal. See, look at this problem carefully. I think you need to a little bit focus. Then only you can work out this problem. Concentrate for a minute. Okay, so I'll tell you the methodology. You can easily work out. See, this is a signal given to you. Okay, so this signal, immediately you can notice one thing. This signal, what is that, Gokul? This is like a U of. You might have learned this kind of waveforms. I hope you can recall. What is this waveform, Gokul? Can you see this waveform?
Continuous time waveform only,
yeah,
sir.
Yeah, continuous time waveform. But what kind of a signal it is? What kind of a signal it is? Can you see it clearly?
Step.
What kind of
Step signal?
Yeah, U is step signal. Okay, so you have to understand that very clearly. First of all, U of t signal, how it looks. You should know that. Then only you can solve this problem. U of t signal is a step signal. Okay, so step means how it looks like this. Okay, this is the time t, this is U. So the value is equal to 1 for all time. Okay. So this signal is going to be like the value 1 for time t greater than or equal to 0 otherwise. That's why I asked you to spend some time on the basic building block signals. Step, impulse and ramp. Okay. Then only you will be in the question to work out this kind of. Once you know this, then what is U of t minus 3? Same signal shifted. Okay, like this. 3 units. So if I am going to define this signal, how do you define this signal? Can you help me out? Narayana? Value will be equal to 1 for time t greater than or equal to 3. Okay, otherwise 0. So that is this signal. So now when I am going to take these two signals, U of t minus U of t minus 3, what do I get? Can you imagine that? What signal I get? Can you subtract this from this?
Sir, it's in the shape of rectangle starting from 0 to 3.
Yeah, that's all. You have to understand that. Okay, so once you understand that, the rest of the problem will be clear. So this is the kind of signal you will be getting when I'm going to subtract these two. Okay, U of t and U of t minus 3. U of t minus 3, U of t. So that's the same manner the signal also looks like. Am I right? Look at this. This is a sampled version of the same signal. What is U of n? Sampled version. Can somebody help me out? What is U of n? The value will be equal to 1 when? What is U of n, man? Anybody from the class? How do you define the signal U of n? Will be equal to 1 when n greater than or equal to 0. Greater than or equal to 0. Otherwise 0. The same manner. In the same manner, however way you have defined U of t, the same manner you are going to define U of n. Okay. So then how this signal looks like? You can clearly visualize that signal. Gradually focus, you can do all these problems. It's not difficult, but don't miss the basics. If you miss the basics, you will not be in a position to work out anything. So go back to the basics again and again to get clarified. So So this is U of n. So this signal is going to start from 0, the value is 1. Then sample 1, 1. Sample 2, 1. Sample 3, 1. It goes on till this is the index n tends to infinity. So there it was like, this is how it looks like, U of t. This is time t tends to infinity. Let's look at this, n tends to infinity, t tends to infinity. This is n, values are all 1. So this is a sampled version of this U of t. Sampled. This is U of n. So if somebody is asking you what is U of n minus 3, what do? You have to start. Okay. The first sample is here, second sample is here, third sample is here. Okay. These 3 samples is going to move like this way. So it's going to start from 3. Goes like this, up to infinity. So this is U of n minus 3. What is this number? Can somebody tell me what is this number? First sample, number, index n. What is the index n for the first sample? N minus 3. Huh? What? It's going to be 3. Okay, 3, 4. Yeah, 3,
3.
4. That's all. You have to understand. It goes on till infinity. Okay. So the value will be equal to 1. So now if I'm going to subtract a U of n minus U of n minus 3, what do I get? Can somebody help me out? The same manner you said, somebody said pulse here. Okay, here there is a pulse. Here what do you get? You get 3 samples of data. 0, 1.
Samples 1, 0, 1, 2.
Okay, is it clear? Is it clear what I'm saying? So these are all the samples you'll be getting for U of n. Good morning, Dan. This is U of n minus 3. I hope you can understand this, Gokul, till this point. Is it all right, Gokul? Gokul?
Yes, sir, I understood.
Now
Yes,
look at
okay,
this.
I understood, sir.
Yeah, now you look at this signal, man. Gokul. Now you can clearly see I'm going to plug in values for k. Okay, and I expected you to draw this waveform for n from minus 6 to 6. I am expecting you to draw around 12 samples of data. Okay, so now then this is x of n. I'm going to draw this. So take this first signal. For example, take this one. Okay, do this. I'm going to do it for this first case. So k is varying between what? K is varying between minus infinity to plus infinity. But I'm not going to take all the k. I cannot draw. Okay, I'm going to take selectively some case. So what I can do is I'm going to choose my index like this. Okay, this is n index. This is 0, 1, 2, 3, minus 1, minus 2, minus 3. So let me choose some values for k. Let me choose k equal to 0. Let us for example, let's choose k equal to 0. What will happen to this signal? Can you see? U of, what do I get? Gokul, can you read out? U of n minus
N minus 4.
0. 3 times 0. Okay, because I'm doing for k equal to 0. Okay. Minus U of n minus 4 times 3
N
times
minus 4.
3 of 0. Is it clear? Now
0.
you can clearly see it is U
Yes,
of
sir.
n minus U of n minus. Is it clear? Now you know what is this signal is. Immediately you know what is the signal. It's going to be a signal like this. Okay, 0, 1, 2. I have 4 samples in between, so that's 4 samples. The fourth sample is going to be getting subtracted with this U of n. Understand? So the fourth sample for U of n, it's going to be like this. And U of n minus 4, it's going to be starting from 4. 0, 1, 2, 3, 4. This is U of n minus 4. So I'm going to subtract these two, means what happens? So only these 4 samples are bigger. That's what I'm trying to do. Once I draw this is my first signal I'm drawing. Then I'm going to add with what? K equal to 1. Then I can choose k equal to minus 1. I can choose k equal to minus 2. K equal to 2. I'll be getting a set of signals. Add all those signals. That's all. If you can do it for 6 samples, that is sufficient. Is all right? What I'm saying? You understand? So take the second signal, for example. See, summation is what? Addition. Okay, remember that. So I'm going to do it for k equal to 1 now. Let's see what happens. So this is the second signal I'm looking at. K equal to 1. See, the k varies between minus infinity to plus infinity. I'm not going to do it for all. I'm doing it selectively for 0, 1, 2, 3, minus 1, minus 2, minus 3, so that I can get some 6 samples of data. That's what I'm looking for. Okay, so k equal to 1, you plug in. What do I get? I get u of n minus 3 minus u of n minus 4 minus 3. Okay, k equal to 1. So it's going to be u of n minus 3 minus u of n minus 7. You're getting the point clearly. Now this signal, how it looks like? Can you guess? It's going to be starting from 3.
From 3 to
3 to infinity.
3 to 7.
This is the first signal. The second signal is it is 3. 3, 4, 5, it goes on. The second signal is going to start from 7. Okay? It goes up to infinity. And these two signals you are subtracting. These two signals when you subtract, what do you get? Right? You get 3, 4,
3, 4, 5.
6. That's all. Okay. So totally 4 samples I'll be getting. So this is the signal you'll be looking forward to. So plug-in values for n, that's all. Okay. Then this is u of n minus 3 minus u of n minus 1. That is this way. Now, if I go to add this signal with this signal, original signal, what you have drawn, k equal to 0. So because for all k's you are adding, remember that. The summation is adding. So do it. You add these two signals, you can clearly see what you get. So 0, 1, 2. Okay. At third sample, you have already 1 here. And that one is going to add it up with this one. So at the third sample, you are going to get 2. So I'm going to have 0, 1, 2. At third sample, it's going to become 2. And then afterwards, again 1, 1. This is the kind of signal I'll be getting. Then you will go for k equal to minus 1. See what's happening. This end also you'll get some signals. So do it totally. I am looking for signals samples from minus 6 to 6 n index. Totally 6 samples is what I'm asking you to draw. So if you can draw that neatly, it is sufficient. Okay, so easily you can work out this problem. So don't get confused. Do it in a very slow way, but in a steady manner. You can easily get the corresponding waveforms comfortably. So read the question. The question is to draw waveforms between n equal to 6 to minus 6. Totally 12 samples is what I'm asking. 13 samples is what I, because n equal to 0 also you have to take it out. Totally 13 samples is what I'm asking you to draw. So I have already drawn here some around 5 samples, 6 samples here. Here, this is 0, 1, 2, 3, 4, 5, 6. So from minus also you have to do. K equal to minus 1 you substitute. K equal to minus 2 you substitute. You get this sample. This 0 will get 2 definitely. You check it out. Okay, it's more like a periodic waveform is what it is. See, if you're going to do it for k equal to 2, you'll get one more one added with 6. Okay, one more signal added up like this. 2, 1, 1, 2 like that kind of waveform. It's more like 2 you'll get here. 0, 1, 1, 2 like that kind of waveform. 1, 1, 2 again you have to get it 6. Okay, check it out. Draw the waveform neatly and check it out. That is this problem. Anybody having difficulty in understanding this problem again? Can you want me to repeat? This
Sir, please repeat once, sir.
Who is that? May I know who is that?
Vamsi, sir.
Vamsi, please listen carefully. I will ask you wherever you have difficulty, you stop me. Okay. So look at the first of all this waveform u of t. Are you comfortable with u of t? Vamsi.
Yes, sir.
Can you define u of t like this? 1 t greater than or equal to 0. Okay, 0 otherwise. Okay, is it all right? That is the first signal. Then u of t minus 3, can you see it? Vamsi. T minus 3.
Yes, sir.
Yeah, this is u of t minus 3. Now, if I am going to ask you what is u of t minus 3, what do you say? It is a pulse waveform. Can you see it? I am going to subtract this one from this one. Okay?
Okay, sir.
That is all right? U of t minus u of t. How does that one looks like? This is u of t. U of minus of u of t minus 3, how it looks like. So when I subtract, when I add these two, what do I get? I get this. Is it clear? Can you visualize it clearly? So that is what this signal is. Now, instead of u of t, continuous time domain, we are going to move towards discrete time domain. Okay, the discrete time domain signal is defined the same manner. N greater than or equal to. Instead of t, it is going to be n greater greater than or equal to 0, 0. Now if I'm going to ask you what is u of n and u of n minus 3, clearly you can see that, is it not? This is u of n. U of n with n 0, 1 to 1. See, is it clear? See this one, u of n.
Yes, sir. Yes.
Yeah, this is clear. Okay, if this is clear, then you can understand this also. N minus 3 sample shift. Okay, it's going to, instead of starting from 0, it's going to start from 3. Now, if I'm going to subtract these two, u of n and u of n minus 3, what do I get? I get these 4 samples. Am I right?
Yes, sir.
The same manner, whatever pulse you obtained here, na? The
Yes,
same
sir.
manner. Is it clear? Come see. Now,
Yes, sir.
take this signal. Now, the signal is little complicated, but you have to apply your mind and focus a little bit. You can easily see through the signal. This is like n minus 3k with k as a running parameter. Okay, running parameter k. Now, what I'm saying is, I'm going to see this signal for some 6 samples or 12 samples. N equal to minus 6 to 6. These signals I want to see in this particular waveform. So what I'm going to do is, I'm going to choose some k equal to 0, 1, 2 like that, and then k equal to minus 1, minus 2 like that. And then I'm going to plug in those values and see how this signal is going to evolve. Is it all right, Vamsi? Can we do it?
Yes. Yes, sir.
Now I'm plugging in k equal to 0. When I'm plugging in k equal to 0, what do I get? I get this. You agree?
Yes, sir.
That is what this signal is. You agree with this?
Yes, sir.
U of n minus 4 immediately in C, you'll get 4 samples like this. You agree?
Yes, sir.
So for k equal to 0, you have drawn a signal like this. Now you have to understand, there is a running parameter with summation series. Summation means what? Addition. Okay, you are adding up all those signals. So you have obtained k equal to 0. Now what are you going to do? You are going to plug in k equal to 1 and you are going to get one more signal. Then you have to add these two. That is what the summation indicates. You are doing it from minus infinity to plus infinity, remember that. But I'm not going to do that. I'm going to do it only for 12 samples. Okay, so naturally I'm choosing some values of k and I'm plugging in and I'm drawing the waveform. So this is k equal to 0 waveform. Then I have plugged in k equal to 1. K equal to 1 if I plug in, k equal to 1 here. What do I get? I get u of n minus 3 minus u of n minus 1. Can you see that signal now? How that signal look like? This is u of n minus 3 starting from 3. U of n minus 7 starting from 7. So when I'm going to subtract these two, what do I get? I'm going to get these 4 samples. Okay, this sample is u of n minus 3 minus u of n minus 1. These are all the 4 samples I'm going to get. Now what I'm going to do, I'm going to add this signal k equal to 1 signal with k equal to 0 signal. Where it is, this one. If I'm going to add, what do I get? I'm going to get a set of samples. Okay, 0, 1, 2, I'm going to get. At 3, here also I have 1. Okay, 3 samples. See, there is a 1 here. And here also I have 1. Okay, so it's going to become 2 here. So in the same manner, if I'm going to do it for k equal to minus 1, I'm going to get some samples here. Okay, the 0th instant impact will be getting 2. The answer for this problem, I'll project that answer. It's more like this. The answer for this problem like this. This is the kind of response you'll be getting. Okay? 2, the 0 sample will be getting 2. Okay? 0, 2, 2, 4, like that you'll be getting. Okay? So
yes.
we're going to, this 2 in fact indicates what? This 2 indicates what? There is a 2 getting multiplied for all the values. Okay? For all the values 2 getting multiplied. That's why instead of 1, in fact, you did 2 here. Okay? The amplitude is getting. So this is a kind of waveform, in fact, you'll be drawing when you add all those signals. Okay, k equal to 1. Is all right? Shall I proceed now? One series, is all right? Did you understand this?
Yes, sir.
Yeah.
Thank you, sir.
Yeah, fine. So now the same manner, in fact, the last class I said x of n equal to 2 of minus n. You simply plug in some n values and see what kind of signal you're going to get. So this is a kind of signal you'll be getting. Okay, this is a kind of signal you'll be getting. Okay. You plug in values, that's all. You will easily understand. So all this, in fact, in the last class we discussed. You can add this signal, it's odd or even. It's an even signal. See here, whatever x of t, x of n is equal to x of minus n. It's an even signal. Okay. The signal causal or anti-causal or a-causal, it's a-causal. Primarily because for both n less than 0 also you have signal, n greater than or equal to 0 also you have signal. Therefore it is a-causal. Only if n less than 0 if you have signal, what is that waveform? It will be anti-causal signal. You have signal only for n greater than or equal to 0, it's called causal signal. Remember that. So you see whether it's aperiodic or aperiodic, it's aperiodic. It's not repeating anywhere. Signal is not repeating. So we can do all this. We share this slide with you. So right now our focus is on this tutorial problems. Let's do it. Where is it? Yeah. First problem, how many of you felt comfortable? Anybody having difficulty in doing the first problem?
Sir?
Can I repeat first problem?
Yes, sir. I came late, so please.
Okay. This first problem is see man. This is the first problem we are going to discuss in the tutorial session. Okay, no problem. You can join. So see here, I am expecting you to compute the total energy for this particular signal. So look at this signal carefully. Phi minus t between this range. Okay, 4 to 5. Then value is equal to 1 between range, and then t plus 5 minus 5 to minus 4. Okay, that's the kind of waveform we are looking at. It's more kind of a trapezoidal waveform. A kind of a ramp increasing. See here, t means you can think of a ramp. A t plus 5. Okay, a ramp, increasing ramp, time shifted ramp. You can imagine that. But right now we are interested only in computing the energy. So we are going to use this formula. Integral formula, most of you will feel comfortable with this. Okay? For polynomial expressions and all you might have used. For example, it is more like a straight line equation. Is it not? A plus dx. Okay, so whole power n dx. I'm going to integrate this. So in that case, it is more like a plus bx, the whole power n plus 1 by b of n plus 1 is a formula. In integration, you might have learned this. If not, remember this formula. Simply take this value. In the numerator, put n plus 1 divided by n plus 1. This normally you do it for integration. Then by b. Okay, b into this n plus 1. So then take the corresponding expressions one by one. Integrate in the range, the integral range like this. Okay, 4 to 5. So take the signal. This is the expression for energy, computing energy. Last class you see x of t the whole square. So 5 plus t the whole square between the range, integral range, minus 5 to 4. From minus 4 to 4, it's going to be 1 square dt, and 4 to 5, 5 minus t the whole square dt. Till this point, anybody having difficulty? Anything you want me to repeat this till this point? Simply apply the formula. Okay, this is the energy formula. So this in fact is more like computing the size of the signal. Imagine this. So in vector notation, normally when I give you a vector like this, so if you want to compute the length of this vector, what do? For example, it is 3, 4. What do? You take the square of it, okay? Square of this, 3 square plus 4 square, in order to compute the vector length. The same manner, energy is more like computing the signal size, okay? Size of the signal. That's why in fact we are squaring it, x of t the whole square dt, in fact we are doing it. Okay, so in that case, 5 plus t the whole square dt, first signal, second signal, third signal. Okay, so then we use the formula. So what is the formula? A plus bx the whole power n is equal to a plus bx n plus 1 b of n. Simply substitute it. So this is more like a plus b x. This x is what this b is. So what is b then? B is equal to 1. What is a? A is equal to 5. So a is equal to 5, b equal to 1. So what is the formula? A plus bx the whole power n plus 1. So 5 plus t the whole cube. B is equal to 1, n plus 1, 3. That's all. Directly you get this integral values. Okay, 5 plus t the whole cube. B, this is n plus 1. B into n plus 1, a plus b, x the whole cube. Okay, so between the limit minus 5 to minus 4 you apply. Then when you integrate t, okay, only dt, you will get t, minus 4 to 4. Then again here you apply a plus bx. Okay, a is equal to 5, b is equal to minus 1 here, and then 5 minus t the whole cube. N plus 1 is 3 again, but b is minus 1. I'm going to have this. Anybody having difficulty in applying this? A plus bx. All right, can I proceed? You want me to repeat again? Anybody want me to repeat again? This one. So simply once you apply, yeah. Can I proceed? Somebody asked something?
Yes, sir.
Yeah, proceed. So directly you can get the solution. Okay, then 5 plus t the whole cube by 3. So it's plugging the values, upper and lower integral values. So then you'll be getting this value. So you'll be getting easily, you can get the 26 pi. This is a very direct problem, but those who are uncomfortable with integration, they will find it difficult. Okay, you go back and learn this basic integral again, then easily you can work out this problem comfortably. Okay, without much difficulty. Okay, but this signal is defined only for a finite duration signal. Okay, it's defined only between, look at this, -5 to +5, that's all. So naturally it's a finite duration signal, you cannot compute power for this. If you average out for time t tends to infinity, power will become 0. So it's only a finite duration signal, it is only energy signal. Always whenever a signal is given to you, check whether it's an energy signal or a power signal. If it is finite duration, energy. It's infinite duration, think in terms of power, that to periodicity property you have to employ. Okay, so there are some signals which are neither energy nor power also, you have to understand that. So for example, a signal like a ramp signal you cannot work out energy as well as power. Okay, so they are neither energy nor power kind of a signal, because both the integral will not converge. Okay, because it's not periodic also. Remember, ramp signal is not periodic. So it's not periodic, it's an infinite duration signal. So naturally you cannot work out time averaging for this signal. Okay, power signals. It's not a power, it's not neither energy nor power. Ramp. Alright? What I said right now, can somebody repeat? What I said right now about ramp signal, can somebody repeat?
Ramp signal is not periodic.
Yeah, it's not periodic, fine. That is another one, the key point. Key point. It's neither energy signal nor power. Okay, that's the key point.
Nor power signal.
Yeah, so there are some signals like that, you have to understand that. So there are some signals which are neither energy nor power. So there are some energy signals, there are some power signals, there are some signals which are neither energy nor power. Okay, that's the first problem. Now look at the second problem. Okay, this is the second problem. See, look at this case. Normally people get confused with this. So when we are working out, when it comes to integration, okay, continuous time domain, we will take like this. Okay. Then we will work out between minus T0 to plus T0, and we put 2T. Okay, if I am going to work out between minus T0 by 2 to plus T0 by 2, I put 1 by T for time averaging. Can you see clearly what I am saying? Between T0 minus T0 to plus T0, I have T0 is equal to 2T0, 2T Z. Okay, 2T0 Z. So naturally I am dividing by 2, 1 by T, 2T in order to average out the signal. T0 by 2 to T0 by 2, I have only T. Okay. Minus T0 by 2 to plus T0 by 2, I have T. So naturally T0 I have. Therefore 1 by T0 I am doing it, the averaging out. Is it clear? That is for continuous time waveform, power computation. But for power computation, when it comes to discrete time waveform, I cannot work out T0 by 2. N by 2 I cannot use. N by 2 because N by 2, 5 by 2 for example, 5 samples I have. Every 5 samples it is going to repeat. If I put 5 by 2, I am going to get 2.5. That's not alright. Okay, samples should be integers. We learned that. So normally you use the full samples, n equal to minus n to n. Then you get 2n. From where this 1 comes, this additional 1? Can somebody tell me clearly?
Amplitude.
No. We are doing time averaging, man. N is the number of samples. Here are the samples. This is the samples, number of samples. N is the index, N is the number of samples. We are dividing it by it. So from where this 1 comes? Anybody from the class? We are adding additional 1. Instead of putting 1 by 2 T0, 1 by 2n, I am putting 1 by 2n plus 1. From where this 1 comes? Can somebody visualize it clearly?
0 also will be there.
Very good. That's the key. You have to understand it clearly. For example, if I am going to start here, 0 sample. 1, 2, 3. I have 1, 2, 3. Here it is minus 1, minus 2, minus 3. So if I am going to start from minus 1 to plus 1, how many samples I have? 3 plus 3, 6 plus 1, 7. 0 samples also has to be taken into account. That's why we are putting 2n plus 1. Okay. So So that idea is important. So once you put it, that one, that's the expression for power. Now what is the expression for energy? X of n the whole square. N infinity minus infinity plus infinity. Okay. So in our this problem, in fact, 1 by 2 the whole power n, the signal existing between n equal to n greater than or equal to 0 and n less than 0, it's going to be 3 power n. Okay. Now what about this signal? See whether this signal it's a finite duration signal or an infinite duration signal. Can somebody help me out? Whether the signal will converge or not, or diverge.
Sir, based upon the power of n, sir, converges or diverges?
No, power or not the power of n is varying. See the entire range of n you have. N from minus infinity to plus infinity, n is there. Okay. How do you say it is a converging series or a diverging series? Anybody from the class? It's converging series means you can employ energy signal. Okay, you can employ energy formula. If it is diverging only, we have to think of periodicity and whether it is a power signal or not. We have to study. But this one is converging or diverging. Anybody from the class?
Converging, sir.
It's converging. How?
If we substitute n is equal to 1 by 2 and n is equal to 1 by 4. So it is
very
decreasing,
good.
no, sir,
Yeah,
exponentially.
Exponential signals already we learned. Remember, that's why I asked you the question. So this is 1 by 2, this is 1 by 2 square. So this is more like the number is between 0 less than n less than. The number is between x is between 0 to 1. Okay. So in between 0 to 1, we already learned that exponent is going to converge. Greater than 1 only, it is going to diverge. Okay, that's the idea. So this is going to converge. This is 1 by 2. What about 3 power n when less than 0? Okay, that's going to be 3 of minus 1. Okay, so that's going to be 1 by 3 kind of signal. So again, that's also going to become a converging one. So naturally, energy signal can be computed for this. Okay, so take the signal, square it. Okay, from minus infinity to 1 minus 1, I have 3 power n the whole square. From n equal to 0 to infinity, I have 1 by 2 to the n the whole square. So these two you have it. Anybody having difficulty till this point? Can I repeat anything? How I have put this? Can everybody can do this till this step? What I have done here, I applied the formula. Okay, this formula. But this integral limit is split up into two. Why? I have defined the signal like this. 1 by 2 to the power n greater than 3 power n, n less than n. I have defined the signal. That's why I am splitting up like this. So now change the integral limits. Okay, I am doing it. Now what I have done, I have changed the integral limit n equal to 1 to infinity. Then this will become minus n. Okay, minus n it will become. Therefore it is 9 power minus n plus sigma n equal to 0 to infinity 1 by 4. Okay, I simply change the integral limit. Nothing happens. See here. Initially, see when I am going to plug in minus 1 here, it will be 3 of minus n. 3 of minus 1. I am going to put 1 to infinity, I am going to put minus here inside, that's all. That's only intuitively you can understand it clearly. Okay. This is going to be 1 by 4 to 4, right? So then I am going to work out something like this. Okay. This can be written as 9 minus n can be 9 to the power of minus n can be written as 9 minus 1 whole power n. That's going to be 1 by 9 whole power n. Is it clear? So all of you can work out this comfortably. Then I got two summation series. But this is not summation series. Why? It's not starting at 0. So somehow I have to make it as a series. What I can do, if it is going to start from 0 to infinity, a power n, the formula is 1 by n minus a, we already seen it. For a less than 1. Okay, remember that. This formula is super important. Again and again, we'll be using the discrete convolution also. Convolution problems again we'll use again. Okay, so this is a summation series, geometric series, formula, don't forget. A power n equal to 0 to infinity, that's important. 1 by 1 minus e. So if it is not here, it is not starting at 0, n equal to 1 to infinity. I can make it as from 0. How? Simply put n equal to 1 here. I'm going to have 1 by 9 square like this. Then take 1 by 9 outside. 1 by 9 outside. It's going to be 1 plus 1 by 9. What is this? This is nothing but summation series. Okay, this is alright. This is more like 1 by 9 the whole power 0 plus 1 by 9 whole power 1 plus 1 by 9 whole power. This is So that is nothing but 1 by 1 minus 1 minus. So this is already I computed 1 by 1 minus 4, it's going to be 4 by 3. You can do it from 1.4. This is energy value. You can compute this, you can see what is the value. Okay. So everybody comfortable with these expressions? Anybody having difficulty in solving this problem? Anywhere? Ramkumar? Any difficulty? Yeah, we can do this problem. Okay. Take out 1 by 9 out, then you get the series. That's the only tricky step you have to do in this problem. Now look at the third one. So what is this signal? Immediately by looking at this signal, in your mind, you should remember our Kepler. This is e power j omega. Okay, remember this. This signal is what? Cos omega t plus j omega, j sin omega. Remember that. So it is a sinusoidal waveform. Sinusoidal means it's periodic. Periodic means it is not energy. Definitely power has to be computed over a period. That's all. Immediately, if you remember that, then it will be alright. E power j pi n 2 pi plus pi by. This pi by 8 is nothing but some initial starting point. Pi phase n. Initial phase. From initial phase it is starting. But it's going to rotate only 2 pi. Okay. 2 pi is a periodicity for this. Always remember that. Okay, one full 2 pi is going to come back here and again it's going to come. So periodicity is 2 pi. Fundamental period. So pi n by 2 is a signal is given. So how do you compute the power? The value of the signal is going to be always what? 1. Okay. So it is going to be cos pi by 2 plus j sin pi by 2. That's the waveform. Then it's going to be cos square theta plus sin square theta. The value is always going to be equal to 1. The magnitude of the signal is always going to be equal to 1. So that's square root 1. Okay. So from this range is now between n equal to minus n to 1. So for each value I'm going to get 1. Okay. When I'm going to start plugging in n's between one time period, I'm going to get one value. So it's going to get 1 plus 1 plus 1 plus 1. Remember that. Okay. So it's more like 2n plus 1 is the value. That's the series. That's the value. So it's going to have value is 2. Okay. It's going to be divided by the same value. Okay. Is it all right? Anybody having difficulty in understanding this? This one, have you understand this clearly? So you plug in values for e power j pi 1, for example. N equal to 0, e equal to 0, value is 1, cos 0 is 1. N equal to 1, okay, 1. For n equal to 2, you will get these values. Okay. So all the values are 1. So from n equal between 2 time periods, you will have 1, 1, 1, like that. 2n plus 1 is there inside that total. N equal to minus n. So that value is going to be okay. So that's the third problem. Easily you can compute the power of this signal. Even though you are saying it's n equal to tends to infinity, it's a periodic waveform, therefore 2n plus 1 by 2n plus 1 the value is 1. The fourth one. How many of you solved this problem? Anyone from the class solved the fourth one? Satyanarayana, did you solve this problem? Alexander?
Sir?
Gokul? Yeah, who is that? Satyanarayana?
No, sir. I'm that minus 1 and 1 that is even part, sir. Amplitude is positive.
This is positive.
Minus 1 and 1, sir.
This problem? This problem? This problem?
See, second problem. I can't see, sir. Second problem.
Which problem, man? You're asking the second problem. This one. This one? This one you are asking?
No, sir. Fourth problem.
Fourth problem. Okay, this one. Yeah. So what is the question? If you carefully look at the question, man, the question is computing the odd and even part for this waveform x of t. As soon as the problem is given to you, you have to remember our formula. Always go back and learn the basics. Xe. Okay, if I'm going to compute Xe, the even part is going to be x of t plus x of minus t. Remember that. and it's going to be odd part. Remember the formula. What is odd part formula? 1 by 2 x of t minus x of minus. So we are going to do these two steps. That's all. You get the answer. Now this is x of t. Then what is x of minus t? Reverse it. Whatever minus 2 is value is going to be here, it's going to be at 2. Whatever is minus 1, it's going to be at 1. Whatever at 0, it's going to be at 0. Whatever at 1, it's going to be at minus 1. Whatever at 2, it's going to be at minus 1. You simply reverse the signal, you're going to get x of minus t. So then simply add. See what I'm looking for is x of t plus x of minus t in order to get the even part. Divided by 2. Okay, that's what I'm looking for in order to get the even part. So I have to add these two waveforms. Add this waveform with this. What do you get? Can you draw in your notebook? Every one of you? What do you get? Simply you can see that clearly, is it not? See here, this is a constant slope here from minus 2 to minus 1, but it starts at infinity, it goes to infinity. So it's like this, the waveform. Okay, so then at 2, what's happening? There is a constant waveform here and there is an increasing slope here. So you could add. Okay, so then what do you get? You see it clearly. So this is the value 1 I'm getting. Here, this is x of t plus x of minus. An increasing slope at exactly 2. Okay. Till this point, I'm going to get constant value. At 2, I'm going to get an increasing slope. So that's what is happening. Okay. See here, key point. Look at this waveform. I'm going to add. This is a slope of increasing slope of 1, and this is an increasing slope of another 1. When I'm going to add those two, what do I get? Every point is getting added, is it not? This point is getting added with this one. So the slope is now going to get increased to 2. Okay, you are getting the point. Slope is now instead of 1, from 0 to 1, the slope is 1 here. But when I'm going to add these two waveforms, from 0 to minus 1, I'm going to have a slope of 2. Okay, that's what is happening. 0 to 1, it's now increased to 2. Now, it's now decreasing, the slope of 1. See here, I'm decreasing its slope of 1 here. But it's constant here. It's decreasing with 1. So naturally, I am going to get a waveform with a decreasing slope of 1. From 2, it's now brought down to this minus 2. Okay, with a slope of 1. Then from there, it's going to become constant. So that's the waveform I'll be getting here. The same manner, we can repeat it here also. Increasing slope of 1 here. I'm adding it with an increasing slope of another 1 here. So naturally, every point is going to get added up. So the slope will become 2 here. So instead of 0 to 1, I'm going to have 0 to 2 slope, ramp, increased in ramp. Then again, it's going to decrease because this signal is a constant value here, and here it's a decreasing slope of minus 1. So naturally, it's going to decrease with a minus 1 slope. And then it becomes constant afterwards. Primarily because this signal will take care from here onwards. Everybody understood this idea clearly? Anybody have difficulty in understanding this? Please repeat. I'll repeat. You understand how I have drawn this waveform? This is important. Anybody have difficulty? Let me repeat. All right. Gautam? Gautam? Gautam, will you understand Gautam?
Yes, sir.
Are you sure? You understand how this slope is increasing from 0 to 2? Why it is increasing from 0 to 2 instead of 0 to 1? Here it is initially 0 to 1, the slope.
Addition.
One slope here. Yeah, you are adding. Okay, you are adding every point. For example, if this is 0.
Amplitude.
Yeah, amplitude you are adding. 0.1 it is. This is also 0.1. So when I add 0.1 with 0.1, it becomes 0.2. So for 0.1, I am going to get 0.2 in this curve. Okay, this curve I am going to get for 0.1 the time axis, the amplitude is going to be 0.2. 0.2 in the time axis, I am going to get 0.4. That's why the slope is 2. You understand? Every point I am adding. But here what do I get? For 0.1 in the time axis, I will get amplitude also 0.1. That's why slope is 2. Is it clear? When I add point by point, I am going to get the slope of 2. In the same manner, I am going to get. So then for x of t minus x of minus t, what do I get? And visualize it. So this is these two signals are there. I'm going to subtract from this one from this one. What do I get? See here. This is till this point 2. Okay. But this is minus of x of minus t. Therefore, it's going to be in the reverse order. See, it's going to start at minus 1. Minus x of t. I'm looking at x of t minus x of minus t. Okay, subtraction. So that's why x of minus t becomes the signal like this, x of minus t. And I'm going to put minus of x of minus t. It's going to start with this. Okay, it's going to be till this point 2. It's going to be minus 1. And then at 2, what happened? Minus 2. There is an increasing slope here, but this is a negative value of minus 1. So from negative value of minus 1 amplitude, it's now moving towards an increasing slope of 1 till this point minus 1. And then at this point, what happens? Minus 1. At minus 1, what is happening? A decreasing slope. And this is also contributing. Okay, this is at minus 1 already. There is a decreasing slope of minus 1. Then it will become constant. Then this is becoming, again, it's going to be increasing slope. Take the problem and look at carefully, you can clearly see it. So then you have to divide both the signals by 2. Amplitude only divide by 2. Okay, then you get the even and odd forms comfortably. Alright, everybody with me? Anybody having difficulty in seeing the signal? Okay. Last problem, you can do this one in the same manner, whatever I said. Here it is going to be cos square pi by 2. It's a periodic waveform. Immediately it's only energy is not existing, only power is existing. 2n plus 1 equal to minus n to n cos square pi by 4n. So cos square is can be written as cos square theta is equal to 1 plus cos 2 theta divided by 2 is a formula. Remember that. Okay, trigonometric identity. 1 plus cos pi by 2 becomes 2 theta means 2 pi by 4. So pi by 2. Okay, and this will rotate. And comfortably can work out this. Okay, so I'm going to take this 2 out, 1 by 2 out, cos 1 by 2 out. Okay. This is your data. Cos square by 4n becomes 1 plus cos pi by 2 again. So energy is not there. Okay, can you see it? Energy is not energy. It becomes infinite energy. Why? This is periodic. So this is periodic. It becomes diverging series. Diverging means unbounded. So naturally energy is not infinite. Only power is existing. You got 1 plus cos pi by 2 power n. So you have 2 n plus 1 ones inside. Okay. For everyone you can. Cos pi by 2 the power n is going to be 0. Value is going to be 2n plus 1. So this is the value 1 by 2. This is 2n plus 1 by 2n plus 1 is 21. This is 1 by 2. Okay, you can work out this problem like this. Over one period, we are going to average it. Fine. So with that, I think I can stop here. Go back and learn this whatever topics I have been discussing with you. Come prepared for tomorrow's exam. By 8:45 it starts. Anything to be clarified at this junction? Tomorrow we'll see how you are going to do the exam. Okay, let's stop. Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Thank you. Do well.